I'd like to welcome everybody back. What we're going to do now is continue on with our discussion about the scientific method. So now that we have come up with a hypothesis and we have determined that we have some sort of objective measure and that it is possible for it to be falsifiable, how do we ultimately arrive at our conclusion? Well, there are two primary methods of reasoning that we can use. We can use inductive reasoning and we can use deductive reasoning. So, with our vitamin C example, we know that 1, fruits and veggies have a lot of vitamin C. 2, people who eat more fruits and veggies are healthier than people who don't and have fewer or shorter colds. Number 3, vitamin C is an antioxidant which can reduce throat and nose irritation. So with these facts and my personal observation that my colds are shorter when I take vitamin C, it seems to follow that taking vitamin C would shorten the duration of a cold. When we combine a set of observations to make a conclusion, we are using inductive reasoning. Now, while a hypothesis reached through inductive reasoning may seem correct and may make a lot of sense, it can still be wrong. So we can make all these observations and we can use inductive reasoning and say this must be the answer. But the thing is, you can still be wrong. If we decide to test this hypothesis to see if it can be demonstrated to be false, then we have now switched over to deductive reasoning. Okay, so if we had stopped with the idea that fruits and veggies have a lot of vitamin C, okay, and we know this as to be a fact, people who eat more fruits seem to be healthier and have fewer or shorter colds, and the idea that vitamin C is an antioxidant, and my observations, and we stop there. That is inductive reasoning, okay? But if we are going to test a hypothesis to see if it's false, or see if it can be demonstrated to be false, then it becomes deductive reasoning. So we can still have looked at all this same information and come up with a hypothesis, but if we choose to test that hypothesis, then now we're using deductive reasoning. To use deductive reasoning, what we do is we take some sort of a general principle to predict an observation. So in our case, we would predict that if we take the recommended amount of vitamin C, then it would reduce the duration of a cold. And it's these if-then statements that are a good indicator that we are actually using deductive reasoning. So let me say that again. In the case that we're talking about, we would predict that if we take the recommended amount of vitamin C, then it would reduce the duration of a cold. So if you see that, you know that we're using deductive reasoning. If we examine the prediction that we made, okay, and again, let's go back. Our prediction is if we take the recommended amount of vitamin C, then it will reduce the duration of a cold. If we look at this, we can see that there are a couple of other possible outcomes. And let's talk about what those are. If you take the recommended amount of vitamin C, then the duration of a cold could increase. Okay, so that's another possible outcome. And a third possible outcome is that if you take the vitamin C, the recommended amount of vitamin C, then the duration of a cold could actually increase. And that would be another possible outcome. And so these other outcomes are what we would call an alternative hypothesis. So our hypothesis is that if we take the recommended amount of vitamin C, it will actually reduce the duration of a cold. Our alternatives is that it would actually have no effect on a cold, or it could actually increase the duration of a cold. And believe it or not, you think that, well, surely we would know if it's actually that, if it would actually increase the duration of a cold. But there are actually times that we can observe something and believe that it does one thing, and because in our general observations we're not putting a clock to it or measuring it, it could actually be the reverse, because a lot of times our perceptions can deceive us, which is why when we use a scientific method, we are not just relying on our perception, but rather that's why we rely on measurements. So, how would we go about testing this? Okay, well, what we would do is take a bunch of people. I don't know, and that's one thing that's actually would be determined as part of this process. But let's say that we take 100 people, and we have 50 people in group A over here, and we have 50 people in group B, and we are going to give all of them colds. Yes, we're very awful people. And we're going to give these people colds, and we're going to do this, we're going to give them an injection, so we know that everybody has a cold and they're all going to get it at the same time. So everybody now has a cold, but group A, or one of our groups, is going to get vitamin C, and the other group will not. In both cases, what we're going to do is measure the duration of a cold. So remember what we talked about? What we're going to do is observe them and be measuring their body temperature. And when their body temperature increases past 98.8, okay, and then maybe we'll have a list of criteria, such as they start getting stuffy noses or feeling bad, and we're going to continue to monitor them until they peak. And then eventually what they should do, their body will fight off the viruses and eventually come back down to normal. And then once they get back down to 98.8, then we're going to consider that being the duration of their cold is complete. And so we will measure their temperature and the amount of time it takes to come back to normal. Now, if the people who were given the vitamin C have colds of shorter duration than those people who were not given vitamin C, then we would conclude that the prediction is true and that we would not reject our hypothesis. If we did the test and there was no difference between the duration of colds between the vitamin C and the no vitamin C people, or if there was an increase in the duration of the cold of time for the people who were given vitamin C and the people who were not given vitamin C, then we would reject our hypothesis. If we reject our hypothesis, then we would need to figure out another hypothesis as to what can decrease the duration of a cold. Because remember, I noticed initially that my colds last a shorter amount of time than the people around me. That is still the case, or at least I think it's still the case. Okay, maybe my perception of that is completely wrong, but we all know that at least it appears that in some people, colds last a shorter amount of time than others. And at least using this one test, it appears that it might not be vitamin C. Now, something to keep in the back of your mind is that that does not conclude our test. Even if our hypothesis appears to be correct, there may be something else going on, and I'm going to talk about that in a minute. But, all of these results that we have just discussed, or all of this process that we have just discussed, goes into a scientific theory. Now, a scientific theory is different from our everyday use of the word theory. All of the results that we have just discussed, let's say that we made our observations and that, we give somebody 500 milligrams a day of vitamin C. I don't know what an actual dose of vitamin C is, so please do not go out and take 500 milligrams of vitamin C. Please consult your doctor, your medical physician before changing any diets or engaging in any exercises or doing anything else. So anyway, that's a disclaimer. But as a result, we gave people vitamin C, and the duration of their colds was shorter. Okay, that can then go into a scientific theory. Now, a scientific theory is different from our everyday use of the word theory. Sometimes, depending upon how we use the word theory, it can mean an abstract thought about something or just speculation or something. I have a theory about this, and this is what I think. That's just pure speculation, or yeah, that would be just pure speculation because I'm just making crap up off the top of my head. But it can refer to a belief about something. This is what I believe. This is my quote. I'm sitting here doing air quotes. You can't see it, but quote theory. Okay. Now, when we talk about a scientific theory, that has a very distinct definition, and it is different from just our everyday use of the word theory. A scientific theory is a well-substantiated explanation of some aspect of the natural world which is acquired through the scientific process and is confirmed repeatedly through observations and or scientific experimentation. And this is distinctly different from our colloquial use of the word theory. Okay? And I keep harping on this because this is a very important distinction. When we talk about the theory of evolution and natural selection, which is pretty darn important in biology, we don't consider it just a notion or an abstract thought about how life evolved, but rather it is a well-substantiated explanation of how life has evolved here on Earth. And that is the same thing for any of the other scientific theories that you're going to hear about. But a lot of times, people who are not scientists and who haven't had a lot of science classes don't realize this distinction, and they see the word theory and they think about it as how they normally every day might use the word theory, but it's different. Okay, and scientific theories are repeatedly confirmed through both observations of the natural world, okay, and scientific experimentation, at least natural world in biology. And all this talk about theories, we keep talking about something repeatedly happening. We wouldn't just do this cold experiment one time. We would repeat it over and over again because maybe there was something I missed. Maybe it was a fluke. The science is not a thing. It's a process, and it really never ends. And so, even when we find out something that appears to be true, we might want to run multiple tests or even slightly different tests, okay, to see if our prediction continues to hold up. And even if we conclude our prediction is true and we do not reject our hypothesis, and we have provided additional support for our scientific theory, then we still want to conduct additional tests. And you want to keep testing because, it's just possible that the first test was a fluke. I mean, if you did it really well and you review your scientific process and you did a really good job setting it up, odds are it's not a fluke. Okay, but then, that's why we want to do additional tests if it's all possible. But if you keep testing and other people keep testing and the hypothesis is still not rejected, then the evidence continues to grow that our scientific theory is probably correct. Okay, and you may also want to know why. Why does vitamin C actually appear to reduce the duration of a cold? Or, what's the minimum amount of vitamin C that I can take that can reduce the duration of a cold? Or does an injection of vitamin C reduce the duration of a cold more than just taking pills or eating oranges? So, I threw out there 500 milligrams. What does 400 milligrams do? What does 200 milligrams do? And so, we keep doing this and we keep seeing that, we did 400 milligrams and people still reduced the duration of a cold for vitamin C, and we did 200 milligrams and it did the same thing. That's still supporting our initial hypothesis about vitamin C, but now it's getting more and more fine and more detailed. Okay, and this is a never-ending process. There are endless variations that scientists can examine until they find out the thing that works best, or why a particular vitamin actually reduces a cold. Until we finally figure out, what's actually going on. But that's what really drives science, and what drives science, because this quest for knowledge is never stops, and we try to find finer and finer detail so we can actually understand the thing that we're looking at. Well, this is as good a place as any to stop. We've been going probably a little bit longer than I normally like to go. Usually I like to keep these to around 15 minutes, and I think we went closer to 20. But let's stop here and take a break, and when we come back, we will continue on with the lecture.